Index laws should be fairly easy, but they do ask you questions in stupid ways. So we need to make sure we know all of index laws. So the first index law is if the same base multiplied with 2 powers, you add the powers. Okay. If it's the same base divided with different powers, you subtract the powers. Anything to the power of 0 equals 1. If you've got brackets a to the m to the n, then that is a to the m times n, so you're multiplying there. Some other ones that are really useful, ab to the n is equal to a to the n, b to the n. Okay, and we can use the example for this one here. If you do 2 times 3 squared, okay, that's 6 squared, which is 36. Okay, now if we apply that index rule to it, if we say 2 squared times 3 squared, that's actually 4 times 9, which is also 36. So we can prove that that actually works. Okay, so that's how that rule works. The divide is the same. A divided by b to the n is just a to the n divided by b to the n. Okay, and it'll work because it's the same as that. They are the 7 index laws you need to know. You need to be clear on what they are and how to use them. The only way you're going to get clear on how to use them is by practicing, and they ask you to do, they start really simple in this exercise, so they'll ask you to do one particular index law. By the time you get down to question 9, right, they're asking you to use all the index laws at once, okay? But you just section it, so you do one index law at a time. So if we actually start with a question from 1, okay, so if we have a look at question 1a, we've got x squared times x to the 5 times x to the 3. Okay, and we're asked to simplify that. It's simply x squared plus 5 plus 3. Okay, if you're going to write out the middle step, that's what you write, because that's what our law says to do. If you're multiplying and they've all got the same base, you add the powers. So down here, all have got the same base, so we're just going to add the powers. So 2 plus 5 is 7, plus 3 is x to the 10, and that's our final answer. Okay, so that's how easy they start, just one index law. Alright, if we have a look at question 4a, they start stepping it up a little bit. So 15a to the 8, b cubed divided by 9, a to the 4, b to the 5, divided by 2a cubed, b over 3ab squared, all squared. So you can see straight away we've got a heap more index laws to worry about. Okay, not only have we got a division over here and a division here, we've got a divide in the middle, we've also got a bracket with powers on it. Okay, so we're going to start by expanding the brackets. Okay, so everything in this bracket needs to be squared. Okay, absolutely everything in that bracket needs to be squared. So we're just going to leave 15a to the 8, b to the 3 over 9, a to the 4, b to the 5 for now. We'll leave the divide symbol as it is as well. Okay, so 2 squared, a to the 3 squared, b squared, divided by 3 squared, a squared, b squared, squared. Yeah? So if we keep that up there, right, so if we just keep that the same again, so 15a to the 8, b cubed divided by 9, a to the 4, b to the 5, divided by, and then we're just going to simplify this section here. So 2 squared is 4, a cubed squared is a to the 6, okay, according to our index rule with brackets. B squared stays as b squared, divided by 3 squared is 9, a squared will stay as a squared, b squared squared is b to the 4. Okay. Now we can start simplifying, okay? Technically speaking, we could have simplified this left side a lot earlier, but I'm trying to make it step by step for you, alright? So let's have a look here. We've got 15 divided by 9. Okay, so if we're going to... So there's a couple of ways to approach this. Let's do it... which way do I want to do it? Okay, so there are a couple of ways you can do this, alright? I'll show you... I might split the page down in half and I'll show you 2 different ways from here. Okay, so down here I'm just going to keep each individual and then we'll deal with it at the end. Okay, we'll deal with this divide at the end. On this side we'll deal with the divide now and work our way down. Okay, so 15 divided by 9, you're going to simplify that to 5 on 3. Okay, a to the 8 divided by a to the 4 is going to be a to the 4, and it's going to be on the top. B to the 3 divided by b to the 5 is going to be b to the 2 on the bottom, which is b to the negative 2. So b to the 2 goes on the bottom. Okay, if you're going to write it on the top, you write b to the negative 2.
B to the negative 2.
And you did it on the top? Yep, that's fine, as long as it's on the top. Okay, but it does actually mean that it's underneath. Okay, as long as you know that, it'll be fine. Okay, 4 divided by 9, you can't simplify, so it's going to stay. A to the 6, I think that was, divided by a to the 2 is a to the 4. B squared divided by b to the 4. B to the 2 on the bottom again, or b to the negative 2 on the top. Okay, so now we've got a fraction here and a divide. Panic stations because we can't do it. What do we do? Nope.
No, you flip the right side.
You flip, yeah. Times. So you flip this guy and make it times. Okay, so 5a to the 4, 3b squared times by 9b squared over 4a to the 4. Now you can cross cancel here. Alright, so I'm going to do that in a different colour because you guys probably wouldn't see this.
Only flip the second.
Only the second one, yep. So I'm going to cross that 3 out, put a 1, cross that 9 out, put a 3. Okay, then I'm going to cross out this A4 and this A4. Alright, and then I'm going to cross out this b squared and this b squared. So what's my final answer? I've got 5 times 3, 1 times 4, 15 over 4. Alright, there's not even any index laws in there, or not any indices left. Alright, see how using each index law separately can get you to an answer that's actually quite easy. Alright, but would you have guessed that the answer to this question here would not have any letters in it and would be 15 over 4, 3.75? You wouldn't, would you?
Absolutely, I guess.
Liar. Alright, so now I'll show you the second way we could have gone, and that's to do this flip back up the top here and cross cancel straight away. Okay, so if we leave 15a to the 8 divided by, we've got b to the 3, 9a to the 4, b to the 5, times by 9a squared b4 over 4a6 b2. Okay, you can actually do some cross cancelling again. So straight away you're going to cross cancel your 9s. Okay, you've actually got, how can we do this easily? If we have a look at the A's, okay, I've got 10 A's on the top, don't I? And 10 at the bottom, so I can cross off all of them. Okay, and if we have a look at the B's, I've got 7 on the top, 7 on the bottom, so I can cross off all of them. Can you see we get to exactly the same answer? Okay, it may be way easier, but this way over here is using the index laws as they're meant to be used, if that makes sense. I don't mind if you do it that way, because while you're saying, yeah, we've got the same number of A's and B's on the top and bottom, you're using the index laws anyway, but you're not showing it. So I recommend while you're working through it, you go down this way. That's just another option. Okay? Now, for the trickiest question. Okay? Let's do 9c. 4 to the n times 7 to the n minus 3 times 49 3n plus 1 divided by 14n plus 2. Okay. Better? Right. So, this is horrible and it gets really tricky. Okay, and the issue is in our bases. None of our bases are the same. Okay, so when you're starting with these kinds of questions, you need to make your bases the same. So 7 is as simple as it's going to get. Okay, so that's one base we're hunting for. All right, what do you think another base we might be hunting for might be? A 2. Why a 2?
7 goes into 14.
Alright, yeah, 7 goes into 14 2 times, and 4 is?
2 times 2.
So we're trying to chase a base of 2 as well. Okay, so that's what we're going to try and do. So to do that, what's 4 in relation to the base 2? So 4 is 2 squared. Okay, and that is to the n. Okay, our 7 is going to stay. I'm going to try and do this all pretty colours so you can see where everything's coming from. Our 7 is going to stay the same. What's our 49 going to end up? So it's going to be 7 squared, right, to the 3n plus 1. Okay, and we're dividing by, what's 14 going to be? I'm going to do 2 because I had blue in my hand, times 7 to the power of n plus 2. Okay, so now we start using our index laws again. Okay, and I'm just going to go back to one straight colour here, but what's 2 squared to the power of n? Sorry?
4n.
No. Using index laws, keeping it in the lowest base possible. Yes, it is. Sorry, yes, it is 4 to the n.
Yeah.
But
14 n.
2 squared and...
nope.
No.
What does index law say?
2 to the power 2n.
That's it. So 2 to the power of 2n. Okay. Times 7 to the n minus 3 was staying the same. What's 7 squared to the power of 3n plus 1 going to be?
7 to the power of 6n plus 2.
Okay. So we've expanded. We've gone 2 times 3n plus 1. Okay, and expanded that out to get this answer here. Divided by, what are we going to have down here?
2n plus 2.
2 to the n plus 2.
And 7 to the power of n plus 2.
N plus 2 as well. Okay, easy, right? What do we do next?
You want to drop out?
Cancel.
Can we cancel?
You don't know.
You cancel the 7.
No,
What's the 7n plus 2? It's going to take the 7n plus 2 out and it'll be 7 over 7.
I like your theory, but no, you can't. All right, the simplest
Because
step.
the number will be gone.
The simplest step is to work on this multiplication here between these two 7s, okay, and add these two powers. So we'll leave 2 to the 2n times 7 to the n minus 3 plus 6n plus 2, divided by 2 to the n plus 2 times 7n plus 2. Okay, so I'm going to run out of space if I keep doing it this big. So 2 to the 2n times 7n plus 6n, 7n, minus 3 plus 2 leaves it as minus 1, 2 to the n plus 2 times 7n plus 2.
What happened to the other 7?
What do you mean?
Goes away when you add
When you multiply these, you add the powers.
the other 7.
Oh, I thought we just changed it back to 49.
No. Multiply, the base stays the same, just add the powers.
Oh.
Alright? So from here, we're now going to look at the 2 to the n divided by 2 to the n plus 2. We're going to look at 7 to the n minus 1 divided by 7 to the n plus 2. Okay, so the index law state we do 2 to the 2n minus n plus 2. Alright, and then we're timesing by 7 to the 7n minus 1 minus n plus 2. Right? So 2 to the n minus 2n minus n is 2 to the n minus 2, and then 7n minus n is going to be 6n minus 1 minus another 2 is minus 3. Alright, and that's your final answer. You cannot get any simpler than that. Alright, so when you come across a question like this, hunt for the smallest bases, the ones that you can't simplify anymore, right, which in this case was 7 and 2. Go through and change all of your bigger numbers into those bases by either making for the power like we did on the top line or multiplying down the bottom line here, and then just work through your index laws one at a time. Okay, so we work through our index laws one at a time and we come out with what's not so hard of an answer. Alright, or not so hard of an expression to work with. Okay?